There are certain defining features that are important to consider when creating a glass material in Maya or any other 3D application. For a very simple glass shader, the most important features to consider are reflection and refraction. In this image, you can see that the surfaces of the goblets are defined in large part by their reflective quality. The background environment, although completely blurred in the picture, is brought into sharp focus on the surface of the goblets. This gives us a strong visual clue as to the shape, the smoothness, the shininess, and even the purity of the glass. In this image, the windows are reflecting the outside environment. Notice how in both images the reflections serve to anchor the object in the scene, to create some visual interaction, to convince us that the object not only is there but belongs there. In addition to reflection attributes, glass also has a transmission attribute, where light is transmitted through the surface, creating transparency. In certain areas of this image, we can see through the glass to the objects and spaces on the other side. This transmission of light is called refraction. When light passes through a transparent surface, it bends, creating some visual distortion of the objects on the other side. The amount of bending is called the index of refraction and is a physical property of the refracted or transparent surface. In our building image, the window glass has a very low index of refraction, resulting in almost no distortion of the objects behind it. Water and curved glass, as used in lenses, have somewhat higher indices of refraction and create more distortion. Different materials like glass, water, plastic, minerals all have different indices of refraction, which can be looked up on a table or adjusted visually in your software. For our purposes, initially, we're going to look at enabling reflections and a refractive index to create a simple, believable glass shader in Maya. Here I have a very simple Maya scene consisting of a three-sided cube with some wallpaper on the side, a little bit of a baseboard, and some floor. And this is really just to give me some context to reflect inside my goblet. The goblet, in this case, is a NURBS goblet, but you can use, either NURBS or polygons. But the thing you want to notice about this is that this is a double-walled surface. There's a certain thickness to the surface, and I was very careful to pay attention to how thick this actually is, because it's going to refract light and become kind of like a lens. So I don't want it to be too thick. I was also pretty careful about making the thickness of it even along the whole bowl of this glass, because again, I don't want to have thicker and thinner walls, because the light and the refraction is going to be a little bit different based on the thickness. Down here for the stem, this is just a single wall surface, and that's going to appear as being a solid piece of glass. So the render of this, just with a default Maya render, is going to look like this. I just have a Lambert material on here first. Okay. The material that I want to put on my goblet is a Fong material. I want to use some material that has a specular shading area. With a Fong material, the specular highlight is controlled by this attribute called the cosine power. The default is 20, and it produces a kind of a shiny surface, but it does have a certain diffuse quality. If I lower the number on the cosine value, that specular highlight becomes more diffuse and the surface looks more pearlescent. If I increase the cosine power, it becomes a tighter highlight and becomes shinier and smoother looking. The default value here will go up to 100, but you can increase this to 200 or 300, or some higher number. For glass, it's not unusual to go as high as 500 or 600, but for now I'm going to leave this at 200, and we can adjust it a little bit later. The specular color, you can eliminate the specular highlight entirely by turning the specular color to black, or if you turn it to white, you'll get a blown out highlight. And again, the default is somewhere in the middle, and we'll deal with that a little bit later. The reflectivity is the amount of reflection that you get, how reflective it is, and the reflected color will override environmental reflections if we want to do a different kind of render. We'll get to that a little bit later. So I'm going to assign this Fong material to my goblet, And let's just do a quick render to see what's going on here. You can see I'm starting to see that little specular highlight here. The next thing I want to do is apply a little bit of transparency to my material. So I'm going to take the transparency here and I'm going to turn it all the way up. Black in this case is the equivalent of 0 or 0 transparency, and white is the equivalent of 1 or total transparency. The color, I'm going to remove all the color from this and just make it black. When I render this, all I can see now is the specular highlight. There's really no definition on this surface at all. There's nothing reflecting, there's nothing refracting. It's just the simple specular highlight. So the object disappears against the background. In order to enable the reflections, what I need to do is change my render so that I get ray tracing. I can do this within the Maya software, and by default, with the Maya software, ray tracing is off. So if I go into the Maya software tab here, open up ray tracing quality and turn on ray tracing, you can see that I have some ray tracing attributes, which we'll talk about a little bit later, but just by putting the check mark in that box will enable it. Now when I render, you can see that I have reflections. I have some desirable reflections and some undesirable reflections. The desirable ones are the ones on the glass, and you can see how I'm now completely defining the shape of this glass by the reflections that are appearing on the surface. My floor is reflecting the walls are reflecting each other, the baseboard is reflecting the floor and the walls, and I don't really like that so much, so I can turn that down by adjusting the reflectivity attributes of those shaders. For the walls, I'm going to come down here. This is a blend shader. The specular highlight is controlled a little bit differently, but my reflectivity is at 0.5, and I'm going to reduce that down to, I'm just going to go all the way down to nothing for that. And the same thing with the floor. I'll take the reflectivity, I'll reduce that to nothing, and the baseboards, I'll leave that at maybe a 0.1 or a 0.2. I'm thinking there might be some glossy paint on there. Maybe I'll do the same thing with the floor, 0.1 or 0.2. Maybe there's a little bit of a wax coating or something on the floor. But that's the attribute that we want to use. So again, my render. Now you can see I have no more reflections in the walls. I have a little bit of a reflection in the floor and a little bit on the baseboard. So I think that's pretty good for now, so that's the way I'm going to leave it. When we turn on ray tracing in the render settings window, refraction is automatically enabled, so the bending of light is possible within my render, but I must enable them in my shader as well. Scroll down to the ray trace options within your shader attributes and set refractions to on in the checkbox at the top. Below that checkbox is a refractive index, which controls the amount the light will bend. I'll set my index initially to 1.5, which is an appropriate setting for glass. Refractive indices for various materials can be found on tables published on the internet, and from these tables I know that an index of 1 means that the light will not bend at all, as in a vacuum. Glass has an index of anywhere from 1.4 to 1.6, depending on the purity. Be careful about depending on these numbers too heavily. There are other factors to consider when creating visually accurate glass. So now you can see that my glass is starting to refract the light, it's starting to bend the light. You can see that looking through the glass, we're seeing some bent light rays. We're picking up some of the floor down here, we're picking up some of the wall over here, and we're also seeing some black around there, which I'll talk about in a minute. One thing I want to point out is the quality of this render. When we start to use these refractions, the default quality of a render no longer is satisfactory, so we're going to have to increase that. That's done in the render settings window under the Maya software tab, and it's the anti-aliasing quality. By default, I have my edge anti-aliasing set to low quality, and there's a little preset here called custom. I'm going to just change that setting to the intermediate quality. You notice that my edge anti-aliasing is immediately upgraded to the highest quality possible. So when I do this render, you can see that I have I have a substantial increase in the quality of my render. Now the black that's being reflected here is actually the background of my camera. You can see that, in my scene, I have really nothing all the way around this cube. It's completely black, and that's what's being reflected around here. So I can change that by selecting the camera, going into the attribute editor, and I can take a look at the environment settings of the camera, and I can change the background color. So I don't really want to change it too drastically, but if I can match some of the colors in here, I think it'll give me a nicer render. So let's go with a blue. I can actually just use my eyedropper here and sample that color. This may be a little bit too light. It might result in a little bit too much blown out reflection there. So you can see how just a little bit of an increase in the value of this is going to increase the value of this reflection. So I'm going to go ahead and turn this down so that I'm really, even though my hue is still over here in the blues, my value is down to like a 0.06 and my saturation is pretty low. So I can play with that setting and kind of simulate some random reflection going on in the edges of this glass. I don't want to go too high, otherwise I'm going to get that that kind of blown out reflectivity. So the rest of this is then going to be a matter of just editing things like the reflectivity, the specular highlight. So if I take my reflectivity here and I increase this to 1, you'll see that I get this kind of mirror finish on my glass. And if I take my reflectivity down to maybe a 0.2, I'll see very little reflection, but mostly refraction. There's another setting that I need to adjust when dealing with glass, and that's the setting called the refraction limit, or the number of refractions. And I need to set this in 2 places. The first place would be in the Phong material. Under the ray trace options, you can see that I have a refractive index setting right here, and right below that is my refraction limit, and the default number for that is 6. The render settings, the global render settings window also has a refractions number in the ray tracing quality section, and by default this is also 6. I had it set to 12 there, but it's really 6. And what this refers to is the number of surfaces that a ray of light has to pass through in order to refract properly. For an observer looking through this goblet at an opaque surface, there would be 4 distinct surfaces that this ray of light would have to pass through. Once it reflects off of the opaque surface, it would have to pass through the same 4 surfaces again, meaning that we would need to set our refraction limit at 8. In this video, we've reviewed the basic material attributes needed to produce a basic glass material in Maya: specular highlight, transparency, ray trace reflections, index of refraction, and refraction limit. In the next video, we'll talk about some more advanced concepts in building our shader tree that will allow us to incorporate the Fresnel effect we mentioned earlier. This will lend a very subtle but very important degree of realism to our renders.